Hi, welcome to day 3 notes from Unit 1, Math 3. Mr. Weissert here. I wanted to go through and talk about properties of parallelograms. We're going to use those properties to solve problems. In some cases, prove that a parallelogram based off of a shape based off of a graph is a parallelogram. And let's talk about a parallelogram first. I think most of y'all know what a parallelogram is. It's a shape with opposite sides parallel to each other. Not congruent. Not all sides are congruent, but definitely the opposite sides, which we'll talk about later. But what we do want to write, at least at the minimum, is some arrows to show that these are parallel, going in the same direction. So two pairs of opposite sides parallel, and it's a quadrilateral, of course. So that's the definition of a parallelogram. Now, parallelograms are one of the most used quadrilaterals because they can be drawn into lots of different properties, and furthermore, shapes like rectangles and squares and rhombuses are all parallelograms. So really, this is kind of a base model for some of the other ones that you see. So talking about those properties, you'll find that in a parallelogram, not only are opposite sides parallel, but they're going to be congruent to each other. So you might only see the congruent markings. And even if you're not given the fact that they're parallel, if you've shown that the opposite sides are congruent to each other, it's going to turn out to be a parallelogram. So that's one of the main ones. Also, opposite angles are congruent. You'll find that this angle here and that angle have the same measure. They look like they have the same measure, and in fact they do. If you extend the parallel lines, we can prove that with parallel lines and transversals from the first day notes. And the same thing here with these two angles. Now, rarely are they all four equal. That's if they're a rectangle and they're right angles. But at least two pairs of opposite angles are congruent in a parallelogram. Coming from that, we talk about consecutive. Consecutive means next to. Are supplementary. So supplementary angles add to 180. What we're dealing with here is if I know this angle, so if I just call that x, then I know this angle is going to be 180 minus x. Okay, they're going to be supplementary. Again, from this fact that opposite angles are congruent, that will be x, and this will be 180 minus x. And all four angles add to 360, but any two next to each other are going to make a 180. They're going to be supplementary to each other. Reason number 4, or theorem number 4, is diagonals bisect. Remember, that means cut in half. So to show that diagonals bisect each other, you're going to draw a picture. Diagonals are connecting the corners. And the diagonals aren't going to be congruent to each other, but they will meet each other halfway. So that segment is the same as this one. And this segment, it looks smaller in this diagram, but it is the same as that segment. So diagonals bisect each other, which means that this point is the midpoint of that segment and this segment. And finally, if I draw one diagonal, and we did congruent triangles yesterday, but if I draw one diagonal, I can make two congruent triangles, okay? Because think about it. If I know opposite sides are congruent, I know that those are congruent to each other, and these are. And by the reflexive property, I know that that shared side is congruent to itself. So these triangles are going to be congruent by side, side, side. So I've just formed two congruent triangles by just drawing one diagonal in a parallelogram. Pretty cool. And we mainly use this one here, this one and that one when we're proving on the graph, and then we'll use all of these when we're just solving equations and figuring out different problems. So let's start with some formulas that we're going to need on the graph, because we will need to use slope, distance, and midpoint. And let me tell you what the slope's going to be used for. The slope's going to be used to prove opposite sides are parallel. The distance will be used to prove opposite sides are congruent. And the midpoint formula will be used to prove diagonals bisect each other. So I'll take you through one of each of those examples so you can see the difference. Let's refresh each other on what the slope formulas and distance and midpoint formulas are. So slope, it's not mx plus b. Don't think of a line. Think of what is m, and that's rise over run. Or more formally, we do y2 minus y1 over x2 minus x1. So when we have two coordinates, as long as you're subtracting in the same direction, reduce that fraction, you'll get a slope that you can compare to the other slopes in the drawings. You want to do it for all four sides, not just two of them, all four. Distance, formula for distance, you got a big square root. It's the difference in your x's squared, comes from Pythagorean theorem, plus the difference in your y's squared. And then once you square them and add them, you take the square root. That's your distance. Again, we do that for all four sides. So we can compare and say, do the opposite sides have the same distance? So are they congruent or not? And finally, the midpoint formula is a coordinate. And that coordinate is the average of your x's. We do an average by adding the numbers and dividing by the total amount. So we'll use 2x's, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And this proves that diagonals bisect each other. We only do this with the two diagonals. So don't do the midpoint of the sides, do it of the two diagonals. Do the distance and slope of the sides if you're doing it that way. So memorize these formulas. They come up in almost every math class you take. And let's get started. So to start, you're given a diagram. I always try to graph the points first just to see, is it a parallelogram, just by the way it looks. Now that's not enough to prove it, but at least you get an idea of, what you're looking for at the end. So point A is negative 4, 4. Point B is 2, 8. Point C is 3, 4. And point D is negative 3, 0. And of course, it looks like a parallelogram. If I could draw a little better, it would look a little more like a parallelogram, but that's all right. So this question says use slope to prove they're parallelograms. So remember, slope is y2 minus y1 over x2 minus x1. Well, we want to get the slope of all four segments. So I'm going to start with segment AB. All right, that slope, and I'm just going to use the coordinates up here. Y2 and y1 is 8 and 4. X2 and x1 is 2 and negative 4. So 2 minus negative 4. Well, that's really just 2 plus 4, isn't it? So this is going to be 4 divided by 2 plus 4, which is 6. You can reduce that to 2/3. So that slope is 2/3. Let's do the next segment, BC. BC, y2 minus y. It doesn't matter which order you go, but I'm just going to stick with right and left. So it's going to be 4 minus 8, which is negative 4. divided by 3 minus 2, which is 1. Negative 4 divided by 1 is negative 4. Next segment, CD. CD. That's going to be 0 minus 4 divided by negative 3 minus 3. 0 minus 4 is negative 4. Negative 3 minus 3 is negative 6. Negatives will cancel out to give you a positive, and again, we notice 4 over 6 reduces to 2/3. So right away you see that, hey, I got this slope the same as this slope. We might be onto something here. BC, and we got one more segment, which is actually AD, which is using that and that. So I'm going to do that right over here. And that's going to be 0 minus 4 divided by negative 3 minus negative 4. Which is really negative 3 plus 4, which is 1. So negative 4 divided by 1 is negative 4. So these two slopes have the same measure. These two slopes have the same measure. Which means what? Does it mean that the opposite sides are congruent, parallel? Does it mean that the midpoint, that the diagonals bisect each other? And with slopes, you want to say that the opposite sides are parallel since the opposite slopes are the same. So our little proof, I guess, if you want to call it that, it's really just a sentence. We would say, since opposite sides are parallel, ABCD is a parallelogram. So that's technically your answer because we proved the opposite sides were parallel because we proved that the opposite slopes had the same measure, which gives you parallel lines. All right, let me do the next one. I'll cut that and put it on the next slide so we can make it a little bit easier. All right, so in this case, we want to show that ABCD is a parallelogram using distance, which means that we're looking for opposite sides to be congruent. Remember, that's our goal here. We want to show opposite sides are congruent with distance because that's a length. So the distance formula, square root x2 minus x1 squared plus y2 minus y1 squared. So I'm going to again list the same segments out. AB, that coordinate is, I don't have the coordinate written, but if I remember correctly, if I'm looking at A and B, my x's are 2 and negative 4. So that's going to be 2 minus negative 4 squared. My y's are 8 and 4 squared. And you can type this all in your calculator at once if you want. I don't necessarily recommend doing that because it doesn't really get you to understand what the numbers are coming from. But if you want a quick answer, here's how I do it. You get about 7.2. And that also can be done by hand. I mean, 2 minus negative 4 is 6. 6 squared is 36. 4 squared is 16. 8 minus 4 is 4. 36 plus 16 is 52, which is a little above 49. So 7.2 seems legitimate. But I'm going to go ahead and write just the number there, just to make our life a little bit easier. So 7.2. I'm going to do the same thing for the other three sides. I won't take as long for those. We'll plug in those segment formulas into the formula. The x values are going to be 3 and 2. So 3 minus 2. The y's will be 4 and 8. So 4 minus 8. And getting that distance, we get, oops, sorry. 3 minus 2 is 1, 1 squared, plus 4 minus 8, which is negative 4. Remember, a negative squared is a positive, so if you're doing this by hand, make sure that you do that as negative 4 squared is positive 16. That's going to get you about 4.12. I'll just say 4.1. And we'll do the same with the other segments, CD. CD is going to be x2 minus x1, so 3 and negative 3. 3 minus negative 3 is 3 plus 3. That's going to be 6. And the y's will be 4 and 0. So 4 minus 0. That's going to be 4. So 6 squared plus 4 squared. That same thing as here. That's going to be 7.2. You can double check that in the calculator. And finally, we'll do AD, which is going to be negative 3 and negative 4. And my y's will be 0 and 4. And that's going to be 4.1. I will just verify that with you guys on the calculator. Notice how I'm typing it in. You can do negatives. Just be careful that you distinguish between the negative and the subtraction sign. Pardon my writing, but that is 0 minus 4 there. And I forgot the parentheses. And so there's your 4.12. 4.1. So you'll notice that these two distances are the same. And these two distances are the same. So since that's the case, since opposite sides are congruent, A, B, C, D is a parallelogram. And there's your answer. Since opposite sides are congruent, A, B, C, D is a parallelogram. There's your proof. There's your reasoning. There's your answer. All right, one more graph proof, and then we'll stop this video so you can practice those on your day 3 assignment. All right, so this one is my favorite. I like this one because midpoint. I'm lazy, so I like to do the least amount of work possible. So the midpoint formula only has to be done twice, but you're not doing the midpoint of AB and CD or BC and AD. You're doing the midpoint of the diagonals. So think about segment AC. If you connect those two, it's pretty obvious, at least to me, that the midpoint is somewhere around here. So to verify what that is, we want these midpoints to be exactly the same. So we're going to get the midpoint of AC first. It doesn't matter which one you do first. I'm going to do AC. That coordinate is negative 4, 4. I think. Okay. It's being slow on me. All right, so negative 4, 4, and and C is going to be 3, 4. So the midpoint of that, watch carefully, it's the average of your x's, so negative 4 plus 3 divided by 2, and the average of your y's. 4 plus 4 divided by 2. Well, what is the average of the same number? That's that number. So 8 divided by 2 is 4. Negative 4 plus 3 divided by 2 is negative 1 divided by 2, which is negative 1/2. And 4 divided by 4 is 8 divided by 2 is 4. You're welcome to write negative 0.5 if you prefer. That's up to you. Personal preference. We'll do the same thing with BD. This is going to be negative 3, 0. So negative 3 plus 2 divided by 2. And 0 plus 8 divided by 2. Well, negative 3 plus 2 is negative 1. So that's negative 1/2 again. And 0 plus 8 is 8. 8 divided by 2 is 4. So you notice that these are the same. They are identical, which means that that point is the midpoint for both diagonals, which means both diagonals are bisected, which means diagonals bisect each other. So since the midpoint of the diagonals is the same, diagonals bisect each other. That has to be your reason for that. That's your answer. And the midpoint formula work was your proof, was your way of getting there, okay? So that is it for the graph proofs. Now go on and get your examples done, and hopefully you do well. And if you have any questions, please ask me. Thank you.